Hey guys, Mr. B here, bringing you another awesome math video. This one is on solving a linear system using substitution. So I've got three examples here, three slightly different examples that I think will take care of pretty much anything you might see when it comes to solving using substitution. So this is the first example I have here. We have two equations, 1 and 2, and they are both in y equals mx plus b form. So this is actually a really good thing. When they're both in y equals mx plus b form, it's actually sort of like a, I call it solving using comparison. It's just like a different name within substitution. Now it's still substitution, but basically all we have to do, since they're both equal to y, what we just have to do is let these guys equal each other. So we're basically just comparing the two equations. So now we have to solve. So this is where you need your practice solving linear equations. So if you need a little bit more practice with that, I have a few videos on it, so you might want to check those out. So I add 3 to both sides. So then I have 3x to both sides, sorry, so then I have 8x on that side. Then I can subtract 1. Subtract 1 is equal to negative 16. Divide both sides by 8. X is equal to negative 2. So then what I can do is sub that number back into one of the first equations, either 1 or 2, doesn't matter. I'm going to sub it into 1 just because I don't want to have to deal with all the negatives in the second equation. So y is equal to 5 times negative 2 plus 1 is equal to negative 10 plus 1, and that's negative 9. So there's my y. So the important thing to remember, and I'm sure your teachers probably talked about in this in class, and I've talked about it in my classes, is that the solution to a system is a point. So we always have to say the solution is negative 2, negative 9. So that first coordinate is x, and the second is y. So make sure you do that. Make sure you let your teacher know that you understand that the solution, all it is the point on the graph where the lines cross. Alright, let's try another one. So this one, we do not have y equals mx plus b. Instead, we have an equation here, equation 1, that's x equals negative 3y plus 1, and this other one is in some other different form. So this one, again, the first step is already done for us. Really, with substitution, we want to get one of the equations such that it's equal to a variable. So this one's already equal to x, so we don't really have much to do. All we're going to do is we're going to sub 1 directly in. So we're going to take this guy right here, and we're going to sub it in there for x, because we already know that equals x, so we'll have this 4 times negative 3y plus 1 minus 3y is equal to negative 11. So that way, now we have an equation here that only has y in it, so we can solve for y. So now I distribute through, so I have negative 12y plus 4 minus 3y is equal to negative 11. So I distribute it through that bracket. Now I'm going to combine some like terms. So I have negative 12y minus 3y, so that's negative 15y. And in this step, I'm also going to subtract 4 from both sides just to get things on the right side here. So then that's negative 11 subtract 4, that's negative 15. Divide both sides by negative 15. And the y is equal to 1. So that's a nice number. So now when I want to find x, I'm going to sub it back into the equation that I have x equals. So that's the first one. So if I look here, I'm going to have x is equal to negative 3 times 1 plus 1. So that's negative 3 plus 1 is negative 2. So there's my solution. X is equal to negative 2, y is equal to 1. So my solution, negative 2, 1. So this is, a slightly harder example, but still not really the hardest type that you can face. So the third type is where we don't have any of the equations initially solved for a variable. So there's neither one solved for x or y. So we have to choose one to solve for x or y. So it doesn't really matter. What I always say to my students is that look for a variable that's by itself. It doesn't have a coefficient. So I have a bunch of options here. I have y that doesn't have a coefficient in the first equation, and x and y in the second. So I'm actually going to take the first equation and solve that for y. So I have 2x plus y is equal to 11. So I'm going to subtract 2x on both sides. It's 11. Subtract 2x. So then I'm left with y is equal to negative 2x plus 11, or you could have had 11 minus 2x, kind of like it's there already. So there you go, that's what y is equal to. So now what I'm going to do is I'm going to take that and sub it into the second equation. So it's now y minus x equal to 4. X minus y is equal to 4. So x minus, we have to be really careful about the negatives here. So this is a place where common mistakes tend to happen. So I have a subtraction sign in front here. It's really like the same as distributing through with a negative 1. So make sure that you do that. So I'm left with x. So that becomes plus 2x, and that becomes minus 11 is equal to 4. So I'll combine these x's, that's 3x, and I'll add 11 to both sides. So that ends up being 15. So divide both sides by 3. X is equal to 5. So now I can take that x equals 5 and sub directly back into this guy, to the equation I solved for y equals. So I'll have y is equal to negative 2 times 5 plus 11. So that's negative 10 plus 11, which is 1. So there's my solution. 5 and 1. So make sure you write that again, show your teacher that you know what you're doing. Alright guys, so I hope this video helped. It was kind of short, but still nonetheless, there's 3 different examples using substitution. So good luck, and thank you for watching.